this section, I want to spend just a little bit of time looking at how some of the control structures are implemented. Now, you should all have played with some of this at the assembly language level over the last few courses that you've taken, where you've gone through, and in assembly language you had to go through and do something like a switch statement. You've had to go through and create loops of different kinds. So I want to take a look at that style of idea, or how some of this stuff is actually implemented. So let's see where we can get to here. Again, for the most part, we're looking at some kind of conditional branches to implement these control structures, right? Something where you've got wherever your test for the while loop is, or your test for the switch statement, or your test for the while condition, you've got some kind of a condition that you're looking at, and then you either branch to some label within the program or you don't. So at the assembly language level, you should all have seen how this stuff works. Well, from a higher level perspective, if we didn't have all these fancy loop structures and constructs available to us, we could still get by and do it ourselves if we just had our if statement, our goto, and some labels. And essentially, we could go through and build our own loops. If we were clever about it, we might even manage to make them more efficient than the kind of generic versions that the compiler implements for us as for loops or while loops or whatever it might be. And again, you're just thinking of it, okay, instead of our conditional test and branch, we've got an if and a goto. But under the hood, it's probably doing exactly the same thing. Now, obviously, this is going to be less readable, it's going to be less convenient, it's going to be less safe, but I just wanted to take a little bit of a look at some of the structures that we'd be thinking about. Again, if we're thinking about just a loop in general, if the idea was something like a while loop where you're saying while some condition, do the body, and then afterwards jump out of the loop. Well, if we invert the condition, then we can basically say if not that condition, skip the loop. Go to whatever the label is after the end of the loop. And if that doesn't execute, then we just drop straight down. We do all the statements in the body of the loop as usual. And at the bottom, we make sure we go back up and start the loop again. So we just have a goto statement that jumps us back up to right before this if statement. All right, so if you didn't have a while loop, you've got essentially 2 lines and a couple of labels to add, one label at the top, one label at the bottom, and you've got that same kind of structure available to you. Now, obviously, most high-level languages, you're going to have this kind of thing available to you, but if you find yourself working on a stripped-down processor someplace, you might find yourself working also in a stripped-down version of a language, where there are features that you want to implement yourself, and you have to stop and think about how to do it. So just have in the back of your mind that you can do this stuff even without the features that are provided for you. Similar idea, switch statements. If you've got some big giant switch statement where you're going to go through and say, well, if it's this, do this, if it's that, do that, if it's this, do this, and you've got all these different blocks of code with little break statements or whatever it might be, delimiters somewhere in there to indicate where this particular block starts and stops. Well, if we've got a bunch of different cases that we want to handle, then we can do it similarly. We have a bunch of if statements at the beginning, one for each of the different cases. So if we get a match for the first case value, go to code block 1, and that would be the label for the chunk of code for the first block. And then you've got another one. If it matches the second value, go to the label for the second block. If it matches the third one, go to the label that matches the third block, etc., etc., etc. And then if none of those are used, right, this is going to jump automatically to the first block of code for a match. If it doesn't do any of those, then we just immediately follow it with whatever code we've got for the default case. And at the end of that, you say, okay, well, once I've done, I just want to get out of the switch statement. So somewhere you've got a label that's after the very bottom of your switch statement, and you're saying, okay, well, after I've done my default stuff, I'll just jump to that. And then what you would have is a whole sequence of chunks where you've got the label for a code block. So you'd have a label here, let's say, for code block 1. You'd have the actual code for it. And then, again, you'd have something to say, okay, I've done the chunk I was supposed to do. get out of the switch statement, jump to the label that's afterwards. Right? And so for each of these blocks, you're just going to have that exact same idea. A label, the code block, and a jump to the label that's following the switch statement. So again, you can do all this sort of thing yourself relatively easily. So just to go through our usual process of playing with some of this ourselves, let's have a quick look at what that might look like. So here we've got our do-it-yourself control C file. And here we're going through and seeing just exactly the code structures I just talked about. So we're trying to create a while loop where we say while x is less than 4, print it, increment x, and then go back and repeat the loop. So doing this with just labels, if statements, and gotos, right? We've got this idea that we've got a label for the top, we've got that condition, and what we've done is just inverted the continuation condition. So instead of saying if this condition is true, continue, we're saying if it's not true, skip out of the loop. So if it's not true, skip past the code for the loop. Otherwise, we have the body of the loop, just exactly as we would have earlier, and at the bottom we say, okay, I've done this pass, let's go to the top and check again. And then similarly, kind of weirdness I can get going on here, our emulation of the switch statement. Right, so we've got a switch statement we want to emulate where we're looking at the value of some variable x. If it's 0, we want to do this block of code and then quit. If it's 1, we want to do this block of code and then quit. If it's anything else, we want to do this block of code. So just as we were talking about before, we'll have an if statement that says, okay, if it matches that first value, go to the first block. If it matches the second value, go to the second block. If it doesn't match either of them, do this. And once it's done this, we skip past the end of the switch statement. And similarly for the first block, we do its block of statements and then skip to the stuff after the switch. For the second block, label, do it, and then we've got our chunk of code following the switch. I omitted the goto here since it's just the next statement in line anyways. But again, you can quite happily go through and implement this stuff. Let's see if I can get out of this. And we'll make sure we're up to date here, and we will try running it and just make sure it doesn't blow up on us. Yeah, so we've got our loop that went through 3 times, right? Well, x was less than 4. We had our value of x hard-coded in that one so that it just picked our default case. But again, we've got basic control that we can do with just ifs and gotos. And if there's ever a situation where you're needing or wanting a type of control structure that your language doesn't support, stop and think about it. Is there a way that you can get that behavior yourself? Now, you might not want to resort to gotos and labels to do that, but there's often a way to go through and get the same effect yourself in a different way. Now, just because the language doesn't provide the capability doesn't mean you're stuck without it. All right, we will leave it there for now.